mode.
Hi everyone, thanks for joining this session of Cambium College on service provider applications. Presenter today is going to be Alan Desjardins. Hopefully I got that right. He's one of our regional technical managers for the Northeast US. If you have any questions, feel free to type them in the text box on the right as always, and we'll get to them throughout as you type them in or all at the end. And without further ado, here's Alan.
Hi, good evening, everyone, and thanks for taking a little time out in your evening for us. So we're going to talk about service provider applications, a major, probably the largest marketplace that Cambium Networks services. So what is a service provider? We're going to talk about that. We're going to talk about some of their common fixed architectures, wired and wireless, show some deployment examples and a couple of case studies, and just basically make sure everybody understands what we're on about when we talk about service providers. So there are different types of service providers you find in the marketplace. Traditional wireline sort of service providers. It could be your local telephone or cable company, for example, in that example. Wireless, when they say wireless in this sense, we typically are thinking of cellular providers like Sprint or AT&T or any of the other providers across the globe that send the signal to your little handset. They're dedicated internet service providers. The only thing that they do as part of their business is strictly to provide an IP type connection to a customer. They don't generally, although sometimes they do dabble in voice. It's not their primary business. Sometimes they do dabble in video, but that's not their primary business. And then there's the WISP, or Wireless Internet Service Provider. Again, this has been the strongest point in for Cambium Networks. It's a marketplace we have served with distinction for probably the last almost 20 years, for as long as that marketplace has existed as a viable marketplace. So service providers looking to deploy the following scenarios as it shows here. Residential access, that's getting the voice, video, and IP to an individual home. Business connectivity, and then turnkey networks for municipalities, enterprise, or industry. Anybody who needs a private network of their own for their own use that may or may not connect to the public internet. And here at Cambium Networks, we provide a complete end-to-end solution. We like to say that we got a piece that fits in just about every portion of the network you can look at, from the long distance. In this case, with the PTP 650, which has the record shot of 238 kilometers for the longest unlicensed point-to-point link, sending high-definition video, voice, and data. The PTP 820, which can make links in the right frequency band under the right conditions out past about 30 miles. Distribution access, this is what I call the neighborhood level. We're generally talking typically around the 10-mile range, although in some terrains where the area is friendly to it, like say Kansas or West Texas, you can have distribution access go out to 20 miles, but 10 is pretty typical. And then edge access. In this particular scenario, we're getting down really close to where the customer actually touches the network, to their home computer, to their handheld telephone device, to their laptop, tablet, whatever device. And we service all of these products with point-to-point, multi-point products, and indoor Wi-Fi or outdoor Wi-Fi devices, as well as some other proprietary solutions. And all of these products can be managed under what we call one pane of glass with our CN Maestro solution. Can give you the ability to plan, manage, check the inventory, update the firmware, check your support and warranty status, all those sort of things that you would want for your wireless infrastructure. So another shot of the family of products we have. Again, from Wi-Fi across to distribution to point-to-point. So as Cambium Networks has traditionally been strongest in the wireless internet service provider or WISP market, we generally do it with a multi-point radio infrastructure. So that's one fixed location device. We either call a base station or an access point that sits up on a tower, a high building, what have you. That's any place that has the ability to see lots of rooftops. And we connect into homes and businesses with subscriber modules. And these devices, effectively, I describe it, it's like a wired cable modem network, but without the wires. So as long as we have a connection, a clear path back to the access point, we can deliver voice, video, and data in an IP stream to these devices. So you can see the architecture here. We have the internet cloud connected to some sort of routing device at the core of the internet service provider's network. Connected to a device we call a cluster management module, or CMM, and that device has a unique role where it injects a timing signal onto the radios that are up on the tower, access points as we call them. That timing signal allows us to get twice as much done with half the amount of RF spectrum as most of our competitors through the use of what we call back-to-back frequency reuse by using GPS synchronization. So no matter where you are on planet Earth, any two Cambium radios can be synchronized to each other because they all use the same reference in the sky. A little closer look of that infrastructure. Again, the IP network, as we go from the little blue circle at the bottom, the IP network router there, we come up the line to the thing that says SS. That's a surge suppressor. That keeps the lightning from and other electrical pulses from doing damage to the core network. Through the cluster management module, or CMM device, that provides the timing sync and the power to run the access point or base station cluster, and we can support up to 12 of them with one CMM on this network. Why would I need 12 of them? Perhaps I'm in a particularly dense populated area, and I need that many devices to provide a reasonable connection to all my users. And sometimes I might use access point devices in different frequency bands because they have different propagation characteristics. The higher frequencies tend to not go quite as far and not penetrate obstructions very well, but can deliver the highest speeds. So that's up around the 5.8 gigahertz band. Or if I go down to, say, 900 megahertz, I don't have as much throughput generally because I don't have as much spectrum available, but I do have an increased ability to get through foliage and other things, so I can reach those customers who might not be able to connect otherwise. You can see I've got my little lightning bolt showing the RF connection, and in this case it goes to a subscriber module on the roof, our typical PMP 450 subscriber in this example, through a surge suppressor, and in this case into our CN Pilot R200. That's a home Wi-Fi router that, while it looks and appears a lot like the sort of router you might buy at Office Depot or Best Buy, it's actually a carrier-centric device. So it's more like the one that if you're a subscriber to, let's see, AT&T or who's Time Warner this week, one of the major wired providers, they tend to buy the routers in bulk because they can be core managed. Well, the R200 allows our wireless internet service providers to core manage these devices as well. Through that device, I can provide power to the outdoor subscriber radio. I've got up to 802.11 AC Wi-Fi inside. I've got RJ11 jacks that I can plug into the home phone service and deliver dial tone. And there's even some USB ports on there that I can use for file sharing or printer sharing and stuff like that. So again, it has all the features that a person would expect in a home Wi-Fi router, but it delivers it in a package that a service provider would use to manage and control that device so that they can deal with customer problems and issues much more effectively and keep that customer healthy and on the air. So taking a wider look at the carrier Wi-Fi services. So this is where we can deliver Wi-Fi to the edge. Some of our service providers do this and enjoy this. So it allows them to not only use the multi-point radios to drop an IP connection into the home and then extend it with a Wi-Fi router in the home, but you can create virtual networks over the home routers and business routers that allows a service provider to say, allow a customer who's a paying customer on their network to connect anywhere where their network exists physically. So if they have presence in the mall, if they have presence in neighboring homes, they can do it with a separate SSID VLAN configuration and some configurable rate limits so that it doesn't hurt the actual hosting customer's traffic. And as a result, you can get a fairly nomadic signal, Wi-Fi signal around town with one of these systems very well. It also allows using Wi-Fi to offload from cellular networks. Imagine, for example, we've got this Wi-Fi hotspot that's right next to a sporting event, and the cellular infrastructure around the sporting event, because you have tens of thousands of people to converge in this one location for a couple hours time, a couple times a week. It just totally overwhelms the cellular network. It allows them to offload some of the traffic onto the Wi-Fi network for people whose handsets allow that, not just for data, but for their actual voice connections as well. We can do location-based services. That's the ability to tell approximately where somebody is. So if I know I've got a particular access point installed in a particular place, for example, I've got it mounted in a coffee shop on Main Street in a small town, and I know exactly where that is, and I can tell when any device is connected to it. I can further do things like perhaps, I see the customer's connected and they're walking by the coffee shop, perhaps pop up a little coupon, hey, 50 cents off a cup of coffee if you'll stop in. That kind of capability is available with location-based services. I can get some pretty deep analytics to analyze what's going on with these people as they pass through the network, and manage, control, and improve their experience on the network. So some of the benefits of this, the ability to grow networks to thousands of subscribers. We're able to do that, again, with some of our leading edge technology, frequency reuse technology that we have in here, and the ability to scale lots and lots of devices and connect them to these access points. The ability to manage right down to the end device the connection, so that an operator sitting at the core of the network could take a call from a resident who may call and complain, my internet seems really slow. They can have a look and say, well, I can see from looking at your home router that you have 19 devices connected. And that's when the cat comes out of the bag that, oh yeah, they did share their password with all their neighbors and they're all using their network for free. That's a common call we get, we've heard from. And the ability to provide support through the system. So let's see. We've got a couple of case studies. This is eolo in Italy. They're a large internet service provider in Italy. And it says, like it says, the fastest growing service provider, and they're providing video, voice, and data services through their fixed wireless network. And as you can see in the photo, it's not exactly in the friendliest of weather territories. And yes, this network is functioning that you see in the photo. The people are connected to it and operating. So I get the question a lot of times in some climates, what about if the system gets ice and snow on it? Well, you can see here, it's not really that much of a problem, actually. As long as the stuff's cables have been properly weatherproofed, all the equipment has been built temperature hardened, so it's fine. It's fine with the snow on it. The snow will eventually melt anyway, but it's fine while it's there. And just so that you know, Cambium products have been deployed at McMurdo Station in Antarctica and on the military training ranges in Death Valley, which pretty much gives you the full spectrum of temperature ranges available on planet Earth. So they're using a product called a massive multi-user or MU-MIMO. That's using our PMP450M to provide connectivity in a dense urban area. So perhaps there's a very large town beneath this hillside where this site is connected. It's an unlicensed distribution network, and it can provide some tremendous capacity, and it can do it on very little spectrum. Another service provider, second largest service provider in Eastern Europe with 100,000 broadband subscribers, a company called ORION. Again, they're triple pay voice, video, and data network. And they're using our lower cost ePMP unlicensed solution for their distribution network. INEA in Poland. This is rural connectivity, provide broadband to all residents. And one thing I like to point out with the Cambium products, we tend to do very well where there are more acres than there are people. And the reason for that is that the cost to deploy wireline connection to houses that start to get miles apart from each other gets really expensive and very difficult for service providers to provide a return on investment for. With a wireless network, it takes a lot of that cost back out of it. It makes it very, very reasonable to deliver those services. So in this case, we've got triple play, and the same reason the wire services were time consuming and not cost effective. Too much wire, too few customers down the road to make either putting fiber optic or coaxial or cable solution into the ground. So as a result, they used unlicensed backhaul radios and unlicensed multi-point radios for distribution and access. So like I say, a majority of our customers are internet service providers, wireless internet service providers, or WISPs as we call them, giving us the ability to provide rural connectivity in low subscriber density areas, places where there are many more acres than there are people. Specialized service offerings for residential and business customers, the ability to give different looks, feels, and services to those types of customers, with streaming voice, video, and data, and all of it at very competitive prices. We can get a lot done with radios that would just not be economically feasible with a wired solution. And yet another internet service provider. This is Comsur in Italy as well, serving the province of Parma, 8,000 subscribers. And in this particular case, they wanted to overcome the digital divide for business and residential customers, folks that had no connectivity at all. They came into the rescue and provided point to multi-point connections to those end customers with unlicensed backhaul connections to get the signals to these remote areas. The same scenario is playing out all over North America as well. So they use an ePMP unlicensed distribution access network to get into the homes, as well as the PMP 450M. If you look at the photo there, you will see, I'll take it from the top of the tower with the triangle. That's a point-to-point radio link going in one particular direction. To its right is an ePMP base station. To its left, behind the white rectangular box, is another ePMP base station. Just below that is the PMP 450M massive multi-user MIMO. That's the one multi-point that could deliver the most capacity, up to 500 megabits in a 20 megahertz wide channel under the right conditions. And below that, some licensed point-to-point links down there. That would be like the PTP 820, for example, that could be connected to those radios. And then we're here in North America. This is BLIP Networks in Illinois, just downstate a little bit from our headquarters in Rolling Meadows. They started with low-cost, unsynchronized 802.11-based equipment. That was a cost-effective way to get started, but you eventually reach a point with an unsynchronized solution where on a structure like this water tower you see, I can see many more roofs that I could possibly serve because I run out of available spectrum and I run out of available capacity pretty quickly. The ability to drop in with either the ePMP product, as they did with our Elevate solution, allowed them to synchronize. Suddenly they could get twice as much done with half the spectrum. Their ability to add customers to the access point or base station devices went up, and as a result, they were able to provide a pretty robust solution just by using the right equipment for the job. And then this another case study. Again, this is Telemar, Italy. A lot of business in Italy. Another triple play service provider. And the same scenario where they had an unsynchronized multi-point network up there first. They hit the spectrum and capacity bottlenecks, so they came in and they dropped a PMP 450 network over the top of it and decommissioned the old network, and were able to scale up to provide connectivity to many more customers with the same amount of spectrum. And then a really large service provider here in North America. This is Big Bend Networks. If you've ever been out to this part of West Texas, I for a time lived in San Angelo, not too far off the edge of their footprint for Big Bend. There's lots and lots of miles between houses in some of these areas out here. It's very rural. Their service territory covers 18,000 square miles in a varied terrain from flat plain to mountains. And they're in the middle of an AT&T territory, which one might think would make the competitive situation a little more difficult. But the problem with the AT&T territory is they were mostly relying on old twisted pair copper to get to all their customers. So it drastically restricted the availability of a high-speed internet connection, if it was available at all, in the distances that you could get any speed. So only a fraction of the people inside this footprint could actually experience anything that you would recognize as high speed. So they first put in fiber and DSL to 3,000 of their subscribers. This is in the neighborhoods where it totally makes sense, where the wire distances were totally able to pay for themselves. That's a natural first move and a logical one. Then they use point-to-point and multi-point to reach the remaining 2,000 subscribers where fiber and copper was just too expensive. And as a result, they were able to overlay this entire territory and even win over 1,000 and counting of the AT&T subscribers, because they had a superior service offering than what the wired connectivity partner could possibly provide. And this particular region, they did it without any government subsidies or anything like that. The ROI had to be positive for them to do that, and they were able to cost justify it. In fact, we've had customers making money with wireless internet service provider networks since before the federal government was putting any money toward those efforts at all. So I like the statement that they have here, that they've hung their hat on being innovative and creative, not afraid of finding a new way to do things. You can't solve problems if you're locked onto a particular way of thinking or discipline of thought. So they see wireless as just another way of getting to their customers, not competitive to wires, not a strange and mysterious technology, but one to embrace and add alongside the rest of their offerings. And those that are the most successful are the ones that take this very same approach. So in summary, why would service providers look to Cambium to provide equipment? Because sometimes fiber and copper are not cost effective. In fact, the further apart the houses get, the more that becomes true. Sometimes it's right-of-way issues. I've had private networks that were much cheaper to connect wirelessly because a rail line ran through, and right-of-way through a rail area can be very difficult. Sometimes it's geography, a river, a lake, something like that. That makes it easier to just put in a wireless network to get the job done. More often than not, I've had people put in a wireless network as redundant to their wired network, and often found that the speed on the wireless network was faster than what they were paying for on recurring basis for the wired network, so it became the backup at the end of the day. Service providers trust us to build, operate, and maintain their network with our equipment. They're responsible for their customers making sure it works, and we're responsible for making sure that they can do their job. Everybody makes money. So that's what I had for you for a look at service providers tonight. Are there any questions?
All right. Yeah. Please, if you have any, ask them now. We did have a few comments. Just a guy saying he just realized that he has pretty much every single Cambium product in his network. You know, everything from 650, 820, 450, E400s, E500s. Awesome. I would implore
I'd
you.
love to hear that.
Yeah, exactly. We would love to hear about it either on the community or if you would email me directly and we could work on it. Maybe we could even get a white pages document for you or case.
Yeah. And definitely post your photos. There are always ongoing photo competitions if you've got some interesting installations.
Yep, and sometimes you could even win stuff. Let's see, we do have a question. Is the CN Pilot dual band 2.4 gig and 5 gig? Yeah.
Most of the parts are. There are one or two that are single band. You'll just have to look at the array of options and choose the one that works for you.
So I believe more specifically, the only one that is single band is the 190, which is about to come out. It's the really low cost one. I believe even
and the EPMP single band outdoor hotspot as well. Yeah.
Right. So all of the other CN Pilot lines between the 200 or the 201 in any variation and beyond should be dual band.
That's correct.
At least dual band. Because I believe the 600, is it the 410 that should be tri-band, or is that the 600?
Yeah, the new one that's coming out soon is tri-band, and by tri-band in this particular case it means that it adds a Bluetooth radio for management access.
Right. Okay. So here we go. Is it possible to sync multiple CMM4s on, like, with different towers?
Absolutely, because we use GPS as the reference source for them. They inherently have the same clock pulse globally. So yes, absolutely.
Perfect. So while we're waiting for some more questions to come in, I'll just go ahead and give my my little spiel here, where just letting you guys know this session is being recorded and will be available for rewatching on our community page either today or tomorrow. And feel free, if you think of any questions later, you could always ask them in the community on the post or wherever you see fit. And we did get another question. What is the longest ePMP PTP link that we know of?
The ePMP protocol limits it to 14 miles. So it has a hard timing limit that no matter how much antenna gain or illegal power you might apply, you're not going to go past it.
And so that's relevant for not only FCC people, but also people who are in ETSI or other regulatory bodies.
It's not a regulatory thing. It's a protocol timing issue.
Got it.
And it's part of the reason why the radios are as efficient and able to deliver as much throughput over the distance as they can is by not letting that timing go wild, but by keeping rather precise control of it. We've got some pretty detailed training material that goes into the hows and whys of that, but believe me, it's for your benefit. We've got radios that go faster, further. That's just not the right one if you want to go really far.
Makes sense. And the one that you would want if you're going really far would be the 650?
The 650 for the unlicensed, or the 820 at the lower 6 gigahertz frequency for the licensed.
Got it. All right. So we'll give it about 30 more seconds. Wait for so many last-minute straggling questions here. Alan, do you have any last-minute statements?
I don't think so.
All right. I do not either. So, well, thank you so much, Alan. That was a great presentation, and thank you everyone who spent your evening here with us It means a lot. Hopefully you guys will, if you pass your test at the end of the session, you'll get I think the prize is an E400 if I'm not mistaken. So,
I didn't know that. That's nice.
yep. With that being said, thank you everyone. Have a nice night.
Have a good night, everyone.